In this video, we will look at a model that has more data points allowing us to increase our confidence in the model.
The mortgage example here, we have a bunch of credit scores and corresponding interest rates that applicants were able to obtain based on their credit score. And you'll notice that in general, higher credit scores have lower interest rates, which is what we would expect to find. So we're going to do some quick summary statistics on this. So we're just going to count the interest rates. There's 40 of them. We'll take the average, again, of just the interest rates. Standard deviation, and that's standard dev, and this is again a sample, so we'll use the standard dev.s function. Okay, so these are our estimates of the average interest rates. A good starting place for a model down here, right? So we know that the average customer has an interest rate of 5.103%. So if we construct our simple model, it's very similar to the one we used for the car payment, where we have a loan amount, an interest rate, and notice that we're going to plug in our average as our starting point for our calculation. And the term, we calculate a payment to be $1493.64. And of course we could construct a confidence interval around that so we have some idea how accurate our estimate is. So confidence.norm, we'll set a 0.05 confidence interval with a standard deviation calculated above, and our sample size. Now we can construct an upper limit and a lower limit for the mean, but we're going to do something a little different than that. We're going to say if I've got, let's say, a 720 credit score, can I predict my interest rate and construct a best case and worst case scenario for my monthly payment for my mortgage as I'm out shopping for a loan? So the first thing I have to do when calculating a forecast is make sure that I've got a statistical relationship between the values that I want to forecast. In this case, I want to forecast my interest rate based on my credit score. So I'm going to first check the correlation between the two. So correlation between credit score and interest rate here. So I give it those two ranges of values to see. Now, negative number doesn't scare me here because it's really how close it is to absolute value of 1 that tells me how strong the relationship is. So in this case, I've got a negative 0.86 that indicates a strong relationship. Because it's negative, essentially what that's saying is that as the credit rate goes up, interest rate goes down, which is expected. So that tells me I have relatively good confidence here that my forecast will be decent based on the fact that there's a relatively strong relationship between those two variables. So to construct my forecast, my known x, or my x, excuse me, is my individual credit score. That's what I'm going to try to predict my interest rate from. My known y's are all of the interest rates that I know, and my known x's are all of the credit scores that I know. So when I hit enter here, I get an estimate from my individual interest rate. And notice that because my credit score is relatively high compared to some on the table here, I'm forecasted to get one of the lower interest rates. And now I can construct sort of a best case and a worst case scenario by constructing my confidence interval around my forecast. So I'm going to take my forecasted amount here and I'm going to add my confidence interval to it to tell me my worst case scenario for interest rate. And I'll do the same thing for my best case scenario by subtracting my confidence interval calculation from my forecasted amount. Okay, so now I have three interest rates values here that correspond to my particular case. I've got the most likely case, which was calculated as the forecast for my particular credit score. That's almost 5%, 4.986%. My worst case scenario would be 5.162%, and my best case scenario would be 4.809%. And I have a 95% confidence that my individual interest rate will lie somewhere between my best and my worst case scenarios. So I can go ahead and plug those values into a model down here to construct a data table to see what my monthly payment will be based on my worst case scenario, most likely scenario, and my best case scenario. So I'm just going to go ahead and reference these values up above. So my upper limit is 5.162%. My most likely case, again, is my forecasted amount. My best case scenario is my lower limit. The calculation that I want to do is based off of my model here, so it's my payment. So now I'm ready to construct my one-way data table. So data, what if analysis, data table. My column input number is going to be the interest rate portion of my model. And when I click OK, I'll calculate the payment amounts for my most likely case again, which is my forecasted amount, my best case scenario, which is my lower limit for interest rate, and my worst case scenario. And like I said before, I can be 95% confident that my eventual payment will lie somewhere between 1444.35 and 1503.63. So the idea again is that we're using statistics, estimates of a population by gathering sample data, running some statistics, average, standard deviations, confidence intervals, correlations, and forecasts to figure out what the inputs to our models ought to be. And in most cases, we're going to calculate ranges of values, so that leads itself really quite well to things like data tables, scenarios, and other what-if analyses.